G'day everybody, it's me again. I'll just give you guys all a much better look at the induction heater now. It's all on boards and things are much neater. That's the coil, the capacitors. They are very dodgily soldered on. That's the best I can do with my iron, unfortunately. We won't go there, but this is all being changed. It's going to have proper bus rails and other nice things, but I'm not going to go into that now too much. That's the coupling transformer. It's I can't remember the number, 38 or something like that, L38 or L36 or something like that, ferrite core. That receives the high frequency AC from the half bridge. Here I'm using a half bridge now instead of a full bridge, just for some testing. I don't need much more heat sinking than that, or any more real airflow than they get from just being vertical. It seems to work pretty well. There is the drive circuit that creates the drive to run the gate drive transformer, which in turn drives the gates on the MOSFETs. That's a TL494 and two MCP1407 gate drive ICs. Over here we have amp meter, voltmeter, of course, for the main power supply cap, the big power supply cap, its bleeder resistor, bridge rectifier, and of course variac for power supply. Yeah, more componentry. We're using 10 ohm gate resistors. I do have some extra freewheeling diodes for the half bridge, just in case it needs to deal with any spikes, which it runs the induction heater extremely cleanly. Yeah, I know it's a resonance circuit and all of that, but compared to driving flybacks, yeah, driving flybacks or those little ZVS type coils, these things get hammered, but they seem to be able to take this kind of treatment much better, as in being resonant tank, isolated drive, and the CT as a coupling to the main tank. Anyway, I thought I'd also show some oscilloscope readings. That's the gate drive. So that's obviously alternating the two MOSFETs between hard on and hard off. There is a bit of dead time due to it being a TL494. I don't mind that really, it saves any cross conduction issues. As I slowly increase the voltage, I should really plug it in first, shouldn't I? That would always help. See how safety unplugged first can sometimes bite you? Sometimes it can also bite you the other way, I suppose, too. But right, so we've got power now. Now you'll notice on the oscilloscope you can see the sine wave coming out of the tank. That's being measured by a 100 times probe on that capacitor there. Now we do have the tank loaded. If I run it unloaded, the current draw just goes through the roof. So right now we're only switching about 25 volts or 26 volts, because that's half the voltage seen by each MOSFET, and it's not even drawing an amp. So we'll get the voltage up. Mm, 75 per side is fine for the moment. Makes us draw about 2 amp. As you can see, our tank voltage has risen. We're still switching just before the peak. MOSFETs are at room temperature, not really rising, very slowly rising perhaps. Our workpiece is getting very hot. Current draw is still about the same, so that makes the power input, what, maybe 300 watts. I'll push that a bit more. We're at 145 volts in on the variac. So we get about, what, 90 per side now. Current draw is going up as the piece heats. Keep an eye on the MOSFETs. Do have a breaker on this just in case, but yep, see now the MOSFETs are starting to warm slightly. Nothing to write home about. Workpiece, however, getting very hot. It's hard to get it on there exactly. It is very hot either way. It's red. Don't mind leaving that cooking for a bit. So we're now up to just passing 3 amp now, 170 volts. We're starting to load the variac, so Inverter current is different to... Oh, I've got to watch my tank here, it's getting very hot. It does actually take two hands to drive this thing at the moment. I do plan to make a PLL system so it will drive itself, but yeah. MOSFETs are up to 40 degrees now. The low side's a little bit higher, nearly 50 degrees. Don't have any active cooling on them, so I won't run it too much longer. But as you can see, screwdriver completely red, almost. Nearly straightened it. Anyway, that's it. It's turned into a bit longer of a video than I was actually planning to do, but it gives you a much better overview of the system and the components and what they do. And yes, it's all thanks to the AC frequency being switched at nearly 80 kilohertz. Have to watch the tank voltage because that's what burns up caps, unfortunately. And I don't want to destroy too many of them. I don't have too many left. Anyway, enough waffling. Thanks for watching.